this is going to be more like an economic data set, so this will kind of be new stuff. I don't think we covered this in the last class. So if you look at the raw data, right, you see essentially 3 years worth of data. These are supposed to be the bills for utilities in an apartment complex, not for the individual residents who live in the complex, but the common area bills for utilities. So, you know, maybe the common area shares a laundry, maybe the common area shares a garage, maybe the common area has some lighting, right? So they're not very much, they're not very high amounts of dollars, but they do seem to vary across the year. You notice that it goes up in the middle of the year and then it goes back down. I think this apartment building is supposed to be from Arizona. So has anybody been to Arizona? Does anybody know what it's like in Arizona? It's hot, yeah, it's very hot. I think there's a city in Arizona called Yuma, which is the hottest city in America. And it can get, I mean, Phoenix can get really hot. Phoenix can get 45 degrees, so I'm sure this place can get very hot. So yeah, Arizona's quite hot. In the winter, it's very nice there, but in the summer, it's not a very nice place to be. All right, so the first thing, of course, is we want to look at this data in time. So what I'm going to do is I'm going to graph this data in time. I'm just going to highlight it. I'm going to skip the time variable for now. I'm just going to highlight column C. I'm in the Reformed tab, if you missed that. And I'm going to insert, in this case, I'm going to use a line graph. I don't know which one of these. This one.
Why are you not using the raw data?
Well, one thing to notice here in the raw data is that it's not in one column, right? These are all utility bills, right? So one of the things I talk about is you might get the data in this format, but that's not really how you want it. How you want it is in one giant column. Maybe you want to have an index for year 1, year 2, and year 3. I don't have that here. I'm going to talk about this time trend variable in a minute. But when I just graph the data versus in a line graph, this is a line graph, I see this kind of picture.
Shows that the utility bills are getting more expensive.
Okay? All right, good. So you already sort of answered my next question. So what patterns do you see here? Because what I'm going to teach you is a way to model these patterns.
You either can say
Seasonal.
Okay?
Seasonal.
So that's one of the things, right? There's seasonality here. How do you define seasonality?
times in which utility bills hike.
How do you know it's seasonality versus just some kind of a random cycle?
Because the spike always happens around the same time.
Okay, so it's repeating, right? So one effect that we can pick out is seasonality. Okay, and I'm going to show you how to address seasonality, okay? And you mentioned something else of it. You said it's always getting more expensive.
The general curve is
Going up.
shifting.
Right, that's called trend, okay? So in time series forecasting, which is what we're gonna look at right now, they usually divide the effects of the series into 4 categories. Seasonality, trend, some other type of cycle, sometimes they call them business cycles or something, right? Some other kind of cycle that's not repeating on a regular basis, right? So, you know, the economy goes up and down. This has been one of the longest growth spurts for the economy in the United States ever, right? The complaint was we were growing too slowly for a long time. Now it seems like we're picking up a little bit of steam, but it's been a long upcycle. And so the growth and contraction of the economy is not a regularly repeating phenomena that you can't predict exactly when it's going to happen. So that's what we're talking about. And then they talk about random variation. Sometimes they call this white noise or just noise, right? That's not really something that you can predict, right? That's just other random events, right? So we're going to kind of focus on trying to pull out these elements in a time series. And in particular, in this example, we're going to do that in Excel. Show you how to get that set up. All right?
So we're at the ones and zeros?
Yeah, did we do this one too?
Yeah, but this can work.
Okay. You did?
Mm-hmm.
See, it's not linear.
Does it?
Yeah.
And this exact.
Okay, that makes me mad though. We should be going on, but why don't we go through it again a little bit, and then we'll move to the next example, just because that's right. So we built some indicator variables. So I guess we talked about indicator variables, right?
Yeah, but I really don't remember it.
Okay, yeah. Let's talk about indicator variables because they're very useful. So essentially, what we're going to do is we can build variables for individual months, or we can build variables for quarters, or we can build variables, right? The first thing is, we kind of identified there's a time trend. And by the way, you can use the same trick that we used before. You can select the data, right mouse click, and say add trend line. And when you do that, you can put the trend line on the chart, and you can see quite clearly there is a trend. I mean, I'd want to know the p-value of the slope, but it looks pretty clearly like the trend is going up. But you also notice that when you do that, your R squared is quite low, right? So the trend alone isn't going to explain this data, right? So that, and we already kind of identified that there's seasonality here. So you can attack seasonality in a number of ways. But one way to do it is through indicator variables. And so let's set up our indicator variables so we can do that. So one of the key things with indicator variables, the key rules you're going to hear me say over and over is if you've got, so an indicator variable indicates whether you're in a group or not. If you've got 3 groups, in the United States, there'd be people who consider themselves Democrats, people who consider themselves Republicans, and people who want no business of either group. So that's 3 groups. You would need 2 indicator variables to represent 3 groups. So here, I'm going to advocate for using seasons, and I'm going to say, I think we did this before, winter, spring, summer, and we'll add fall. But again, you won't need to use fall. Okay, so the purpose of these indicator variables is to capture that pattern that you see in the data. All right, so without spending a ton of time on this, we could define winter as January, February, or March, but in my experience, I've done this both ways, it works better to define winter as January, February, and December. So this indicator variable will indicate when we are in winter. For the other rows, we will put zeros to indicate that we are not in winter. And we'll follow that up with a second indicator for spring. You'll notice I'm only doing 1 year because later I'm gonna just copy this to the other years. And then summer, doing this in a nice symmetric way. And then finally fall will be considered September, October, November. How you set these things up is up to you. There's a little bit of an art in it, but really the key is that, you know, with seasonality anyway, is that they have some regularly repeating pattern. So now that I did that, I'm gonna copy this to the next year and to the next year. And essentially what I've done is I've created a new set of 4 variables that didn't really exist before. But again, the way I decided that was by looking at that picture and sort of seeing seasonality in there. Now, I see that I've kind of messed up here. I gotta clean up one little detail. I'm about to run a regression. I gotta clean up one little detail. I'm gonna insert a column here next to D, and I gotta move this time trend variable over. This is what Ahmed was talking about before. When you run a regression, you might remember in Excel anyway, these variables need to be next to each other. So if you don't have them next to each other, it's not gonna work. All right, so that's our setup. Let's see how well we're doing. Right, remember, if we just use the time trend, we can run the regression if we want, but we can already see the R squared is only gonna be 15%. So let's see what happens when we run the regression with all the variables. Right, so it's gonna
It'll
be,
an error, right?
it is gonna be an error, you're right, you remember now. It is gonna be an error. So I'm putting B1 to B37 there, and I'm putting C1 to G37,
But you don't need the column C.
right? And this is what you want to avoid on your paper, right? You see what happened there, right?
Sorry, what's in the X range?
All the other columns,
All of them. Alright.
all the other columns. So you see what's happening here, right? Something that looks sort of strange, right? Anytime you have this num thing, you've divided by 0,
All these
essentially.
seasons, all 4 of them.
I feel like we did this. We did.
Yeah, we did do this.
You said that, right?
And what did it divide by in this case?
Yeah, all of them.
Well, here's the thing.
All the way down.
Remember, you cannot use, if you have 4 groups,
You cannot use all 4, you have to use 3.
that's correct. So let's go back and do it the right way.
What?
Let's go back and do it the right way, because that was not the right way.
So we can delete 4.
Yeah, essentially. You can delete it, or you can just not use it.
Why is it that?
And this applies only to indicator variables, right?
Yes. When you have 2 groups, male, female, you use 1 indicator variable. When you have 3 groups, male, female, and that other gender, you use 2 indicator variables, right?
I'm sorry, what happened wrong? What was wrong last time?
When we ran the regression,
Yeah.
we got these results.
Yeah.
You see these things?
Yeah.
Those are errors.
Right.
So the results don't make any sense.
Yeah. So what we changed?
So we can't use all 4 seasons. We can only use 3 of the 4 seasons.
Is that a rule?
Yes, it is. It is a rule. Why is that rule true? Well,
Because there will be, like, it will be explained by the numbers.
essentially what it is in our regression, implicit in our regression is an intercept. If you thought of the intercept as data, as a column, it would be a column of all ones. Because I can add these 4 columns together to get a column of all ones, there's going to be a matrix that's going to be inverted, and that matrix is going to have a division by 0, essentially. So if a column is dependent on other columns, this is a linear algebra concept, then you'll have a division by 0. So that's where the rule comes from, Jacob. So if I've got 3 groups, the bottom line is use 2 indicator variables. If I've got 4 groups, use 3. If I've got 2 groups, male, female, use 1, right? Gender, right? That's it. Okay? So let's run the regression again without fall. And when we do that, in spreadsheets.
You only got to miss out fall.
I left out on fall, exactly.
What's why?
It doesn't matter which group you leave out, by the way. It doesn't matter.
They need to be next to each other.
The columns need to be next to
You
each
need to
other.
move time trend so that's next to the winter.
So how are we doing with the 3 seasons put in here? How are we doing now?
Except for one.
Okay? I think I heard someone say all the variables are significant except for spring. Okay? So spring is not significantly different from what? Do you remember this part?
Winter?
Not winter, but
Oh, the one that we omitted.
very good, right? So the one that we omitted in some sense becomes the reference. Let's talk about that for a second because indicator variables are very useful, so let's make sure we get that right. So we've got a model right now that says utility bills, I'll put a hat over it, equal 217.5 plus 2.03 times time, minus 51 times winter, minus 5.59 times spring, and plus 9610 times summer.
Which is against.
All right? So 559 times spring. So what do you think? We might be tempted, right? So overall, how's the fit? First of all. If I said overall, how's the fit?
89% is explained by the
89% of the utility bills is explained by
this trend.
The time here.
the time trend. This is a time trend variable, right? Essentially, it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And we have 3 seasons, right? 3 seasons, right? Spring is what? $5.59. When you get to spring, the utility bills are going to be $5.59 lower than in
No, the one which is.
than in fall, right? So spring is $5.59 less than fall. Summer is $96.10 greater than fall. Winter is $51.51 less than fall. Everything's compared to fall. Now, as observed, we might want to drop out spring. Now what happens? Well, first of all, the model would change a little. The coefficient would change, right? Winter would be less than, what would we compare winter to if spring wasn't there?
Spring.
Well, it'd be spring, but what about fall? And fall, right? So one reason maybe not to drop spring is because when you do, now it's part of the reference group. Remember that? So in the case where you have indicator variables like this, you might just want to leave spring in there because it gives you another different estimate for all the 4 groups, right? If it's fall, by the way, you just take all these out, right? That's the model for fall, right? Right there. That's the model for winter. That's the model for spring. That's the model for summer. Okay?
What if you take out time frame?
Yeah, what if you take out time? Let's see what happens. That's a good question. Let's just take out time. I think we can do that pretty easily, right? So I'm going to go back and run the model. I'm just going to change the C here to a D.
You need to move the column.
Don't, because I just need winter, spring, and summer to be next to each other. They already are, okay?
Can I ask you once more, what would be the exact interpretation of the -5.59 spring? It would mean that generally the bills for utilities in spring will be $5.59 lower than fall.
Correct.
So generally? Or
Yeah, you would say, on average, is what you would say, something like that. It's estimated to be. The key thing is when we have a continuous variable like time, we would say each time period the bills go up by $2.03, right? As each month, on average, the bills go up by $2.03, right? But for indicator variables, you would say when you're in that group, so when you're in spring, right? The utility bills are $51 less than when you're in. I'm sorry. When you're in winter, the utility bills are 51 less than when you're in fall. All right. So I'm going to run this without time, as Raphael suggested. Again, I do not know why this does it in times. I just cannot deal with that. Sorry. Right? And you went from 85 to 78. So, what do you think? 85 to 78. It's not that big of a drop, but it's bigger than we had before, right? Why would you leave time in or not take time out? What would be your argument?
R is bigger when it is in.
It's bigger. It went from 80, it went down by over 10%, okay? So I don't want to focus so much on the magnitude, but it went down by over 10%, right? So that's one thing, right? The other thing is you know, when we dropped it, it was a significant variable in the first place. So it was actually different from zero. So there is a time trend. Sometimes, this is really annoying, sometimes you can have a variable that's significant, small p-value, but not meaningful. In other words, the coefficient is so small that who cares, right?
Such as that one.
This is almost there. Yeah, this is almost there. But you know, the picture and Ahmed picked it out right away, right? When he looked at the picture, right? The picture kind of shows that the data is definitely going up in time. So, just not a huge, strong trend, but
I can get over my head how, if we remove the time frame data, how will the picture look like?
all right. Well, let's do that now. Let's actually take a look. We'll do both, just so because you asked. So going back to the data, I'm gonna wipe out this picture. I'll build it again in a second. All right. So let's do the last thing that we did on this example. Again, just let me summarize. I would leave time trend in. It's significant. It does contribute over 10% of R squared. It's not like nothing, and it is significant. I would also leave spring in, even though it's not significant, because that way I get 4 different estimates for 4 different seasons. Let's do some forecasts now. I'm going to insert a column. Okay, I'm going to put it column C. Actually, I'm going to insert 2 columns, but I'll do one first. And I'm going to extend the data set out as if we're going out another year. This won't be important immediately, but we'll extend it out for another year. So I'm going to pull down the time trend up to 48, and I'm going to copy my indicators. So I've got another year's worth of.
So you just copied the names of the months.
Copied the names of the months, dragged down the numbers to extend it to 48, and then copy the square of data that represents the indicators for a year.
Drag down the numbers.
I mean, you can see the sort of beauty of this example, right? I had this data, and I didn't actually have any X variables when I started. I made up a time variable, 1, 2, 3, 4, 5, 6, 7, and I added indicator variables kind of by eyeballing it. and I've created a model from these 5 variables, or 4, that explains 89% of the variation. That's fantastic. Now, of course, this is a stupid little example from school, right? It's not a real world example, but for having no X variables, that's not bad, right? That's not bad at all. All right, so column C is going to be a forecast. So the way this works is you can actually, so if I want a forecast, obviously, I can sort of plug in. Let's go back to our regular model. If I want to, you can do it this way if you want. Let's do this real quick and you'll have insight about what we're going to do next. So copy those labels down below the model. This
Which
is
sheet are we on? This is going a bit fast.
yeah, sorry. This is the model with all the 3 seasons and the time. Okay?
So we delete the time trim now?
No, we're leaving it in.
Oh, what are we doing now, sorry?
We're just gonna do a forecast for a particular. We're gonna do a forecast.
For the utility bill?
Yeah, for a particular time.
That's weird. I don't have
Okay.
that in the system.
I'm gonna show you a quick way of doing it.
So we don't
All right.
need to do.
So I mean, essentially what I'm gonna do is I'm gonna give you X variables and say plug them in and tell me what what you expect the utility bills to be, right? So we're gonna be in year 4, okay? Year 4, and we're gonna be in summer of year 4, and we're gonna be in month number. Let's see, what would summer be in year 4? Month number. Yeah, month number 7, let's say. So that would be month number 36 plus 7. Month number 43. 43, right? Is that right? 43, is that summer of year 4? Yes, 43 is July of year 4. So we're going to be in month 43. So if you put in a 1 for the intercept, a 43 for the month, we're not in winter, we're not in spring, we're in summer. How much do you expect the utility bills to be?
2172. You just plug the numbers in the equation.
Right, so it's 217.52 plus 2 times 43 plus 0 plus 0 plus 96. Exactly, some product. You can do it much faster by hand, right? Some product. Oh, my first mistake of the afternoon. All right, some product. Let's try that again. Some product. What do you get? You're going to be spending about $401. Again, I'm assuming it's July in year 4. So July of year 4 would be the 43rd observation. It wouldn't be winter, it wouldn't be spring, but it would be summer.
And what happened to the intercept? Why is it 1? Why?
Well, because when I use the sum product command, I want to make sure I add that number. So I just throw a 1 in there, right, to make it easy. I could have done it a different way and just added it after the fact, but, right.
Time trend.
I just randomly picked month 43
Why?
because I wanted to do a forecast for it.
This whole thing slightly went beyond me a little bit.
Okay, so I'm going to do all these forecasts for these months later, and also these forecasts for the earlier months, right? Just to see how well I'm performing, right? But I said, before we do that, let's just, because we're going to enter a really complicated function in, let's just do a forecast for one of them to see what it is. So I picked that month, Jacob. That's all.
Okay.
All right?
Please repeat the last 3 minutes.
Yeah. So I'm gonna do forecasts now using these 3 variables.
On next, it takes a little bit more time to do the regressions because we have to use external.
Okay.
Why is it a forecast when you already have the bill?
Well, I mean, one reason you want to do it is you want to see how far off you are, right? The other thing is I want to see how it's tracking against the bills, right? I know it's going to be pretty good because R squared is 89, right? But I want to see how it's doing. The other thing, Jacob, is I want to see how I want to see what I'm going to do the year in the future, right? Because really what I'm trying to get at here is let's forecast forward in time, okay? Right? So we're gonna enter a complex function in here to make the forecast, right? Essentially, we only have to enter it once, but in case you just wanted to make a random forecast for 1 month, I was just illustrating how to do that, that's all. And so, in this case here, I'm doing that, right? I'm saying, okay, let's make a random forecast for July of year 4, which corresponds to the 43rd observation in the data set, right? Because 1 through 12, 13 through 24, 25 through 36, and then January, February, March, April, May, June, July, 7. 36 plus 7 is 43, right? And July is not in winter, not in spring, it is in summer. Okay? So that would be the equivalent, again, of plugging in 43 here, 0, 0, and 1. Okay? And what my model says is $401 is what my bill is going to be. Okay. And to get that, I just use the sum product. See, here's the tricky thing. If I want to do forecast quickly for every observation, I got to use these coefficients in the model over and over and over. And I want to avoid having to do some complicated thing to use those same coefficients over and over and over. So Excel has a command. What's that command called?
Something trend.
Yeah, I think it's called something trend too.
Trend, just trend.
It might be called trend, right? Cool.
Yeah.
Excel has a command called trend. All right? Let's remember how to use that command, because I'm sure we used it before.
Yes.
All right? Let's do it. So going back to the data, it's trend, right? And you can see it has a number of arguments. You have to think, well, what did we use in our regression for the y's? That's what they mean by the known y's. Utility bills, right? And so we use rows 2 through row 37, right? Those are the known y's. Because we're going to copy this down, make sure that you anchor that range. Right? What did we use as our known x's in our regression? Time trend?
Winter, spring, and summer.
Winter, spring, and summer, right? We ruled out fall because of that error. So once again, you use a semicolon and then you put in the known x's for those seasons, right? Now notice the known x's has to be the same size as the known y's, right? These are like the things that we entered into the regression dialog box. And again, I'm going to anchor these because I'm going to copy this down. So when we ran a regression, we basically passed this data. The only thing I'll point out is when you use a function, you don't use the headers in the function. You can use the headers in the dialog box. All right? Now it says new x's. This is where I think things get confusing. So if I want to predict for January of year 1, that's the first observation in our data set, I would plug in a 1 here, a 1 here, a 0 here, and a 0 here, because January of year 1 is in winter, and it's the first observation, right? And it's not in spring and not in summer. And I would get a number back, right? So we have to tell it the values that we would plug in, right? These 4 variables for that observation. So what I'm gonna type it in because the formula unfortunately is covering the cells I want to highlight. I'm gonna type in.
Highlight from right to left.
Yeah, I can do it that way, right? You're right, Cameron. I can, if I ever remember to use semicolon, I can type it, I can highlight from right to left, right, to get D2 to G2, and that's what I want. So essentially you're telling it the X variables to plug in. And then you put a semicolon. Corrected myself that time. And I think you put in true as your final argument. Something dumb about the intercept. All right? So this is going to give us the forecast for January of year 1. But if you entered it correctly, you can copy it all the way down to the bottom and get the forecast for every period.
And you do that by double clicking on that little bottom square?
That's right.
Back square?
That's right. Let's see what we got. Okay, and sure enough, there's our July forecast, 401. Let's see if it, I'm just gonna see if it, yeah, 400.99. Not sure what that little caution sign is, right? Did you get it, Erica?
My first month came out to 173.
Do you have something different over here?
I did. Okay. So utilities anchored,
Right?
and then.
D2 to G37 anchored,
Yep, anchored, and then.
D2 to G2 not anchored.
D2 to G2 not anchored, yeah, and then
Okay.
true.
So something's probably wrong in your X matrix, in your square of data here. Do you have time trend 1, 2, 3, 4, 5 all the way up to 48?
48, yes.
So then there's probably something small wrong with your indicator variables, something just off
Let's see.
slightly. Because otherwise it would work.
Yeah, shoot.
So let's do this. Let's practice one more time since Raphael asked about it. Let's practice one more time. Let's do the forecast, same forecast, without time. And I will ask. I will check Erica. I'll just come and check your work, Erica, in a second.
Okay.
So let's try this. So it's trend. Put in the Y's, just like before. Anchor that. Put in the X's, but this time I'm not going to use, when I put in the X's, I'm not going to use the time variable. I'm only going to use 3 variables, not 4. All right? So I'm going to put in
Wait a
one.
second, that's what this is. Oh, God. This is a bit quick.
C2 to
Okay.
C49.
So I'm going to put in, right? So I'm just doing the same thing over again, Jacob, except for I'm leaving out column E this time from my analysis.
So equals trend. And why? Why are we doing this?
Because I want to see how badly we do in the picture at the end of the day without using the time trend. Thought it was an interesting question. And then we'll draw a little picture and we'll be able to look at it all. Let's see your, make your thing a little bit bigger. Let's see your indicator variables.
Am I supposed to include
So, well, mine's a different,
No,
Slightly
that's
different
fine.
layout.
1, 1. That's fine. No problem. Can you unhighlight it?
Oop.
Oh, why would you call
So
it?
you got 1, 1, 1, 1, 1, 1, 1, 1,
And you said honor for a second.
and then where's your next 1 there?
No, because you changed it. I'm like, wait. I was thinking,
Oh, that's right.
the Americans say?
just say full.
Foul.
That's right.
Foul.
Foul.
I don't know what to do with my foul.
No,
So
you
do
don't
I not
want
then? So just
That's right. That's totally right.
I don't understand it.
Okay, let's go and check your formula one more time.
And then comma, and then true.
So C2
Huh?
What?
Then true.
to C37. Oh, D2 to G37.
Then comma.
30,
What are we doing?
Okay.
Without time?
Yeah, without time trend. So we're just going to see if we don't account for the time trend, how well we do. Okay, so I'm creating a second set of forecasts.
Couldn't fix my shit.
So you start from F instead of
That's right. That's it. On the second argument and on the third argument.
Third argument was already on that.
Not in column C, but in column D it is. All right? So you'll notice some interesting patterns here, right? If you don't use time, you always get 244.44 for spring, 352 for summer, 262 for fall, and 200 for winter. And it repeats the same numbers because you get no increase over time. Still gives you an R squared of 78. Let's rough it, exactly. All right, if you highlight these three columns, you can build a line graph with these three columns. Let's see how it comes out. Oh, that's real ugly. Let me do this again. Let's insert the columns, right? Here's my graph. Right?
Which one did you choose? The line one?
I chose a line graph, yeah, and I used the three columns.
Alright.
I don't love the colors, right? The blue series, right? The blue series, right here, that's the actual data, right? And, oh, it changed colors on me. On my screen, it looks silver. I think I might be going colorblind. The green series is the forecast that doesn't account for time. So it looks kind of weird, but the green series is the same height each year. There's no trend upward. It seems like the green series is beginning to miss out. There's no data over here, right? There's no actual data. These are forecasts. But it seems the green series is starting to miss out pretty badly over here, right? The red series is at least jumping up over time to account for inflation or whatever reason the bills are going up.
So that really tells us that we cannot remove time trend.
Yeah, I mean, it's more evidence that maybe, because there's more error here, right, for the green, it's missing that whole top. The other thing I noticed is that even the red series is missing, I guess that's July, right? July has a real peak in it that is getting missed even
So
by.
now I'm a little bit time trend. If we keep going with more forecast over more years, you're just gonna see the green stay at the same level.
Yeah,
And so that still has a p-value of 0, like if it was significant. So
well, it's still picking up the fact that there is seasonality, right? I mean, the green's not doing too bad. What you see actually, the green, what it does, Raphael, is it picks up, it sort of does the average over the years. So the green one is actually above the blue one in the first year, and it's below the blue one in the third year.
Right,
See
but,
that? And it's pretty much right on top of the red and the blue in the second year, right? It's sort of,
but it's not going up, right?
no.
But the other two are going up.
That's right. The other issue is you generally don't want to forecast too far out in the future because you don't know if it's always going to be going up, right?
So, Ken, my question is also about tomorrow, because you mentioned that we're gonna do a bit of a sensitivity analysis for tomorrow, but we kind of did that today, so what is the quiz tomorrow?
The quiz is on optimization, not on this. This is a new topic.
What kind of portfolio?
It's not on portfolio, don't worry. It's not on that. Yeah, so what we just finished covering. So why don't you take a look at the practice quiz and see if you.
Oh, okay.
It all starts to merge together into one big Excel nightmare.
Okay.
For me, you know, like.
Yeah. Well, take a look at the practice quiz. I think you'll be like surprised. You'll be able to.
Maybe practice quiz is free.
Yeah, they're there right now. They magically appeared. Yeah, I'm not a big fan of this without time, so I'm going to delete that. Sorry, Raphael. No hard feelings. I like this one much better. It captures it. It is missing on July though. It is missing on July. And I have an answers that shows that exact thing. If you want, I can give you a quick example of this. So the moral of the story here is that you can use regression with a time variable and with seasonal indicator variables to forecast time series data that is in time, like economic data, like forecasting sales at your company, for example, right, which is economic data in time, right, which may be seasonal. I would assume, for example, auto sales is seasonal, right? More people buy cars in winter and spring, and slows down in the fall generally, right? Although maybe the mix of cars changes, right? Maybe people buy more trucks or more winter.
No, capital is doing it.
Yeah, right. So you can use this type of technique to make those kinds of predictions. What was I going to show you? Oh yes. Let's see if am I still logged into this. I bet I'm not. Come on. I seem to be struggling with the internet here, so yes. Oh, really?